Welcome back, everybody. In today's video, we are going to kind of go in the reverse order that we've been doing in the last video, where we used to have an equation and we wanted to graph that polynomial equation. Now I'm going to give you some type of information about a polynomial equation, and I want us to be able to write the original equation. Okay? So all we're going to be doing today is writing original equations, and if it's not possible, stating that it's not possible. Okay? Important note here, in many cases here, there are infinitely many number of possibilities. We're going to have to write one. All right, so the first three problems, we're going to write a linear equation. First one says crosses the axis at x minus 3. Sorry, x equals 3. So it's going to be y equals x minus 3. Now, are there other answers that will work for this? Sure is, but that's the most easy, basic method to write a linear equation that crosses the axis there. For b, you want them to bounce off the axis at -2. Well, in order for it to be bouncing, it would have to be an even power, so it would have to be 2 or higher, but this is a first degree. So this one is not possible. And for c, if it does not touch the x-axis, that means it has to be parallel to the x-axis, which means it has to be a horizontal line. All horizontal lines are written in the form y equals some number. So pick a number. How about 7? America's favorite lucky number. Next slide, quadratics. All right, so the first one, we want to pass through the axis at -2 and 6. So that would be x plus 2, x minus 6, both to the first power. Okay, now if you want to multiply it out, x squared minus 4x minus 12 would be acceptable. Either one would be perfectly fine answer. Second one, bouncing off the x-axis at x equals -4. Okay, so if we want to bounce off the x-axis at -4, that means we want it to be x plus 4 to an even power squared. Now it's a quadratic. Okay, and c does not touch the x-axis. So that means we're not going to want any zeros for this problem. So writing something like this, x minus a, is not going to work because we don't want there to be an x-axis, a crossing, or a touching. Okay, so in other words, we're going to just do a simple parabola like this, and then you can add any number to it. How about 5? So if we had x squared plus 5, that would just look like this, and it would never touch the x-axis. All right, now we're going to go cubic. Crosses the x-axis at x equals -1, x equals -4, x equals 3. Letter B, bounces off the x-axis at 2 and passes through at -3. C, passes through x equals 4, with no other zeros. Okay, so then maybe what we want to do for this one is kind of like we did for this. Some quadratic that does not have a real answer. So it has 1 0 here, and this would not have any real zeros. So it's going to pass through this one and not do anything with that. D, does not touch the x-axis. All right, well, we're talking about a cubic. It's either going to look like this or this. Either way, it's going to have to cross the x-axis at some point. So letter D is also not possible. All right, let's go quartic now. So fourth power crosses the x-axis at -2, 0, 3, and 7. And they're all going to be first power because it crosses through all of them. B, bounces off the axis at -2, so we'll square that one. And at 3, and we'll square that one. Because it bounces off both. These both have to be even. And then obviously 2 plus 2 would be 4. C, it bounces off the axis at 1, passes through at -3, and at 4. 2 plus 1 plus 1, again, be 4. D, passes through at -1, passes through at 5, and again, no other zeros, so again, we could just write some type of quadratic that does not have any real solutions to it. So how about x squared plus 2? Does not touch the x-axis. All right, this is actually possible because a quartic is going to look like this, right? Or if it's upside down, it would look like this. So this one is actually possible. We just have to make sure that no real zeros exist. So we can do x squared plus 3 and x squared plus 7. And I'm just making those numbers up there. They could be anything as long as that neither one of these will have real solutions to them, which they will not. But it would still be a fourth power because x squared and x squared would be x to the fourth. All right, a couple of assorted ones here. Maybe at this point you can pause this video, try this slide on your own, come back and check your answers when ready, but realize that your answer and my answer may be different. Okay? Try them now. All right, so for A, maybe we have x minus 2 squared, x cubed, and x plus 1. For B, bounce points at -3, +1, and +4, right? But it also says y is always negative, all right? So we're going to throw a negative out in front there. C, a cubic, and has a linear root at 2, and never touches the x-axis again. So x minus 2 to the first power, and then maybe we can throw another one of these in there, x squared plus, you name a number here, how about 3? D, a fourth degree, passes through at -1 and at 4, and no other points of intersection again, so we can throw another x squared plus, pick a number in there, how about 8? E, a polynomial of lowest degree that has an x-intercept at 3 with multiplicity of 2, and at 5 with multiplicity of 3, and at 0, a 0 at -4 with multiplicity of 1. And finally, F, fifth degree, having a cubic factor of -2, and 0 at 3 with multiplicity of 2. And here's an important part here, a y-intercept of 48. So let's think about this for a second. If we put 0 in here, we would get 2 cubed, which is 8, times -3 squared, which is 9. So right now, our y-intercept would be 0,72. We want it to be 0,48. So we have to multiply this by something. And we're going to multiply it by is 48 over 72, which needs to be reduced, obviously, to 2/3. Okay, in the last slide, we're going to do the same thing, except now we're looking at pictures. Okay? So all of this is going to lead us up to here. All right? We just want to get here. That's where we want to get to. So the end behavior, as x goes to -infinity, y goes up. As x goes to +infinity, y goes up. So that means this needs to resemble a positive, even graph, okay? The least possible degree, well, there's 1, 2, 3 turns, so 3 plus 1 would be 4. It's a fourth degree polynomial. The zeros are supposed to be, I know it's a little off there, but it's supposed to be at -5, -1. It's supposed to be at 3 and 5. I tried my best with the graph. 3 and 5. It's crossing through all of them. So all of these are going to be odd. So if I was to create a function that fits this graph, y equals x plus 5, x plus 1, x minus 3, x minus 5. All right? Now for the y-intercept there, if I put 0 in, I would get 5 times 1, which is 5, times -3 times -5, which is 75. But I want it to be, again, it's supposed to be at 2. I want it to be at 2, so all I'm going to do is multiply this by 2 over 75. Last one. As x goes left, y goes down. As x goes right, y goes up. So this is going to be a cubic, right? It's going to look like a cubic, I mean. It's going to be a positive odd graph when we're done. The least possible degree, all right, so there's 1, 2, 3, 4 turns, which means the least possible degree is 5. The zeros, -4, 0, and 5, and 6. It crosses at -4, crosses at 0, and crosses at 6, but it bounces at 5. So a graph could be x times x plus 4 times x minus 6 times x minus 5 squared. All right, last thing, the y-intercept here is supposed to be 0, which if we put 0 in here now, we would get 0. So that is our function that fits the graph. That'll do it for today's lesson. Thank you, as always, for watching my video today.